Hello everyone, welcome to another C++ template meta programming video. Today I'm going to show you how to use and implement your own std enable if, and I am going to use them on functions for this video. So with std enable if, you can make a distinguishment based on certain traits of a type, and this type is can be a template parameter. So let's just write down how std enable if is called, so to speak. So if you're using C++ 11, you will have to write as type name std enable if something and then type. That's C++ 11, and C++ 14 and onwards can be std enable if something. Oops, that must be a _t, and then the arguments, and that's C++ 14 and onwards. All right. So both mean the same thing, except the C++ 11 variant is a little bit more verbose than the C++ 14 variant. And for this video, I am going to use the C++ 11 variant because that is a bit more easier to explain. However, in my project, I am using C++ 23, and that is because in my examples, I am going to use stdprint, and stdprint is a C++ 23 feature. So, std enable if can be used to distinguish certain function overloads, as I said earlier. Basically, it has two arguments, and the first one is a boolean, and the second one is a t, which is void by default. So you can leave it empty, or you can give it a value or a type, say int or whatever your need is. So the bool is necessary for whether or not you want to enable a certain function. So a bool can be true, of course. Let me just remove this. And it can be false. However, only one of the enable if structs is defined. So in a video I showed you, in a previous video, I showed you that you can sort of overload or make a specific implementation for a specific case. You can also do that for enable if, and the two possible values for a boolean are true and false. So say you have a template bool condition, condition, and a class t equals void, and a struct called enable if. I'm just going to use my own naming convention here and not underscores, but you can do whatever you want for, of course. So this is our false condition, or any other condition that is not true. So yeah, this is our false condition, but I'll show you in a while why this is our false condition, while we haven't specialized our false condition explicitly. So we're gonna write another our first specialization, first and only one, by the way, for enable if, and it's going to have a class t, which is this t right here, and we're going to skip the condition because we're going to specialize our struct enable if the condition is true. So we do that by typing structs and typing enable if with true in it. So only if true is passed, then this piece of code is defined. And what it does is, well, as we saw earlier, it has a type alias alias called type. So we're just going to type using type equals t, which is this thing right here. Yes. All right. So yeah, it's dependent on a boolean and a type, and it is void by default. So yeah. You must remember that only if enable if with true is passed is defined, and only if true is passed, the struct enable if has a member alias called type. Otherwise, if enable if false is passed, then it is not defined, and you will also see it is a compiler error. And you may be wondering yourself, okay, but how is a compiler error going to result in a compilable program? Well, that's because this is not allowed. All right, so you must have a false variant, but you also must have a true variant. Only then enable if will work. So let me just write a function, and it is going to print a value. All right. So t can be anything, right? As we saw in a previous video, class t means it may be any type. So it doesn't distinguish any type. It's just, it may be anything. It may be, let's just say, it may be print 3, print 3 points, some very large comma number, print whatever, a or something, a character, print a string. Alright, so it's gonna print these values. I'll just show you real quick. Alright, so as expected, it prints 3.24, a blah blah blah. Alright, nothing really special here, right? But what if, like, we don't want this very large number here. We want 2 decimals after the comma. All right, so that's of course that's possible. We can do we have 2 ways of doing this. We can do the naive way, and we can do the, well, quote unquote correct way. And I am going to show you the naive way first, and that is by writing an overload specifically for doubles. So we're gonna write print double value, and we're gonna print the value. But as I said earlier, we want to specify a floating point formatter, and with the new C++23 scprint, you can use colon.toF, I think it is. And what this does is it rounds up the number up to 2 decimals after the comma, and it rounds up. So in this case, it's just going to print a 3.23, and that's basically it. So this function is going to call this function. This function is going to call this function, and these two are also going to call this function. So again, as I said in earlier videos, the compiler creates a new function called print with int value, and the compiler is also going to create another function for well, double we've already created ourselves, which is not a template function but just a regular overload, and it's going to create another function with char value, and it's giving an implementation too. I'm leaving it empty here, but of course it's printing it. And it's gonna create another one with print const char value, and it's also given some implementation, right? So this is what the compiler creates. This is just a blueprint again. but we are going to remove these because these are not necessary. So, right, nothing out of the ordinary here. It's just a regular function overloading, right? So let's just run the program to see if it works, and it works. And we also see that 3.23 is printed and not the whole decimal number we're not interested in. All right, so what if we change this number to 3.23 yada 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 float? So this is now a floating point number. This function is no longer calling, or this piece of code is not longer calling this function, but it is calling this function. And that's because a float is not equal to a double. So the compiler will sort of choose this implementation, this overload over this overload, and that's because a floating point does not match the double. So let me just show you real quick that it is indeed the case, and as you can see, it is printing the large number again. So, all right, we are just naive, right? We're gonna print, we're gonna create another function, but then with a floating point. Float value. Let me just copy this. All right, fixed for you. This is gonna work again, and well, okay, sure, this works. But okay, this is not longer a float number, but this is a long double. Now, of course, the same thing will happen. It's gonna call this function because there is no overload for a long double, and as you can see, that is indeed the case. So 3.23 yada 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 is printed. Well, you see the point where I'm getting it now. We can create much and much. We can create endless long double. Yeah, we can create endless overloads, right? And the point is, this is not necessary at all. We don't have to create 3 overloads ourselves. We can let the compiler do that, and that is what I said earlier. std enable if can be used to distinguish certain functions on certain traits. So we only want the format specifier if the argument, in this case a floating point value, is indeed a floating point value. So the floating point types in C++ are double, floats, and long double. Now in C++, you have the type traits header, and in this type trait header, there are certain structs defined to query certain traits of your template parameter. And what I'm gonna use today is std is floating point v. The v means value, which is either true or false. Then you pass in a template parameter, and in our case that's going to be t. So this will either evaluate to true or false. And I said earlier that you can use std enable if in combination with a boolean, and this is a boolean, so you can put this boolean into your std enable if, and I am going to show you in a moment how you do that. But first we want to make sure that in this particular case t does not match a floating point type, because we are not passing in a format specifier here. So what you're gonna do is you write type name std enable if, and then you want your boolean to appear here as the first argument. And as I said earlier, you can use std is floating point for that. So you're gonna copy this and paste it right here. And as a second argument, you can use void, but it is already void, so this is optional. However, if this function has to return something, let's say integer, then you can create int here, but don't forget to return a value here, because int is now the return value. But we're not going to do all that, so we can just go on and remove that. So this in fact is now incorrect, because it says if t is floating point, then use this function. However, we don't want any of that because we are not passing the format specifier here. So you can just go ahead and put an exclamation mark. So this function is called if t is not a floating point value. Right. So now we move on to our floating point function implementation, and we can go ahead and write template class t, then type name std enable if t std is floating point v t print t value. So we're asking here, is t a floating point, yes or no? Because you're saying ensure that t is a floating point value. So everything in this function, you can write stuff that is specifically only possible with floating point values. So in our case, that's just going to be a trivial example, namely putting a format specifier within the formatting brackets of the C++20 print, and that is going to be 2.f. So, whoops, that's not correct actually. It's going to be 2.2f, I think it was. Yes, so we know that in this function, t is a floating point value, but we don't know what kind of floating point value it is. It can either be a long double, it can be a double, it can be a float. But that we are not interested in what floating point type it is, because it doesn't matter, because we want to format it with 2 decimals after the separator. And that's what we're doing right here. So we now have 2 functions, one which is called when t is not a floating point value, and one function when t is a floating point value. Alright, so we can go ahead and remove this. And alright, let's just run the program. I'm seeing a squiggle line here. I'm seeing what the problem is. This type name here shouldn't be here, or actually it should be. Let's just fix that. And the same counts for this. So yeah, this should work. Yeah. Okay. So first, I'm not gonna talk about this yet. I'm gonna talk about that no matter what t is, there is never there's always a function for the compiler to not throw an error, all right? Because the way how this works is to trick the compiler into some sort of controlled compiler error, all right? So when you call print3 and the compiler sees this function first, then, 3 is an integer, of course, all right? So this is gonna be evaluated, and it is gonna evaluate to false, obviously. So let me just quickly write the implementation of enable if again, so I can show you what is happening under the hood. Condition and class t equals void, and then we have a struct called enable if, and that's gonna be empty, and then we have another implementation of enable if for the specialization actually, which is gonna have class t and then struct enable if with true, because only enable if with true is defined, and anything else than true is not defined. And then we gotta put it in some square brackets. We're gonna create a type alias, and it is equal to t. So that's this t, of course. So back where I left off earlier. So print 3. 3 is an integer, all right? And what if the compiler saw this function first? All right, it is going to execute this statement first, or that is likely the case anyway. So the t is replaced by an integer. So let me just write this function for a int. So we're gonna write this function where t is int. All right, so it's gonna say enable if. It's gonna, all right, it's okay, then is floating point int, because that's the type what is passed by us, and then print, and then int, and then value, and then this. You can already see it is throwing also all kinds of errors, and that is because well, it obviously makes a lot of sense, right? Because std is floating point int is evaluated to false, so here it's going to be replaced by false, obviously. But we saw that enable if basically it isn't defined except if the condition is true. So if you pass false here, then this implementation is used, but this struct enable if does not have a using type equals t alias. So the compiler is a little bit confused here, because it's seeing this function and thinks, wait a minute, I can't compile this because it is nonsense, right? I cannot do anything with it. So instead of throwing the compiler error, it is going to look at possible other functions that he can use. And we wrote two functions. We wrote a floating when t is a floating point, and we wrote a function when it is not a floating point. Well, let's just write down what the compiler is going to create when an integer is passed in this function. So it is going to be s type name std enable if not that's okay, and it's going to print the value, and t is an integer, and also this is also an integer. All right, so when this function is called, this function is created by the compiler itself, but you don't see that. So first it is going to evaluate std's floating point int, which is well, integer is not a floating point, so it's going to be false. But not false equals true, of course, as you may know. And we see that the enable if struct for true is defined. And we also see that the enable if with the true passed has a type alias within it. And in order to get t, we must type colon t, or that's here actually, colon t, and that way we get void, of course, because void is the default arguments. Let's just put void here to make it a little bit more explicit. So this is our condition, and this is our type alias. So this equals this. So this is void, and type is the same. All right. So t is going to be replaced by void. So this whole thing is going to be replaced by void eventually by the compiler. You don't see that, but you don't have to worry about it because that's what the compiler does. So yeah, that's basically it. You can do very cool stuff with this. Also, it is worth mentioning that this is not a very good example. And also, if you have C++ 17, then this whole thing can be actually replaced by something entirely different. Because in C++ 17 they added if const expr, and let me just quickly show you how that works. So as if const expr, right? If const expr, that's the syntax. It means that you evaluate a if statement at compile time, and you're gonna do basically the same thing but without the enable if statement. You're just gonna write the Boolean expression we wrote earlier within the Boolean value of this struct enable if. So we're gonna write std is floating point, is floating point t. We're gonna do floating point stuff, and otherwise, well, other stuff, because the only thing we know here is that it is a floating point. Otherwise it is not a floating point, but that doesn't mean it is an integer or whatever. It can be endless. The possibilities are endless. So yeah, you can go on and write your format specifier right here, colon 2.f, new line and value. And we don't want to do that for other stuff. So this is basically the same as the std enable if, but you cannot always use this construction because let me just quickly execute the program so you can see. See 3.23 exactly as we wanted, but you can't always use if const expr, and that's because, well, you can maybe forget about this right away, but you can't always use const expr, and that is because, say you have a struct, we want to enable something only when t is a floating point. We must use another template parameter in order to pass our enable if. So now we're gonna something, and then we're gonna specialize it for t, and we're going to type enable if. Let's just do enable if t here because that's a little bit shorter. And std is floating point v t, and oops, I forgot something here. Alright, so in this case, this is already kind of advanced template programming, but in this case you can't use if const expr, because you can't just say if const expr std is same, yeah, bloody bloody bloody. Then you are going to create this struct. Otherwise, that's just not possible. This is not valid C++. It's just weird. This is not possible. So you can just forget about all that. But yeah. So in some scenarios, what I'm trying to say is, in some scenarios you can't use if const expr. If const expr can only be used within functions. All right. So yeah, that's all for this video. I hope you understand it a little bit better now, and yeah, you should just try it on and see how it goes, and you can ask questions in the comments, and yeah, thanks for watching.